Today we're going to be learning how to add and subtract rational expressions. But before we get on with addition and subtraction of rational expressions, let's first look today at a little bit of review of simplifying rational expressions, as with problem number 1 of the warm-up, and for division of rational expressions, as with problem number 2. If you will please pause this, and in your Cornell notes, do this warm-up, please. Okay, let's go ahead and take a look at what we're doing here with these two problems. In the first one here, first of all, you factored out a 4. So now once you factored out a 4, then it ended up with, let's see, you can factor it into x minus 1 and x minus 1. Okay, on the bottom, you factored a 4 out as well, and you were left with x squared minus 1, which factors down into x minus 1 and x plus 1. Alright, now, looking here, I see that the 4's and the x minus 1's divide out, leaving us with x minus 1 over x plus 1. Alright, in the second one, I see division, so I'm going to use the KFC. So we're going to keep the first one the same, and then I'm going to flip the second one, so that's going to be x squared minus y squared over top of 3, and then change this to multiplication. Now let's factor this, so that gives me x plus y over 3 times, and then I'm going to have an x minus y and an x plus y all over a 3. Now from here, in looking at this, I see that nothing divides out that I can see. So because nothing divides out, we just all squeeze it together, and we're going to have x plus y, the quantity squared, times x minus y all over a 9. Let's do a little bit of review for adding and subtracting rational expressions. When you were a 5th grader, you learned how to add and subtract fractions. When you added and subtract fractions, you needed to look, first of all, and see what the common denominator was. So in looking at what the common denominator was, you could see, looking here, you had a c and you had a c. So since you have a common denominator of c, you can add the coefficients together. So it's just going to be a plus a b over top of c. Now, in looking at subtraction, again, we look here, and I see that I have a c here, and I have another c there, so this time I can subtract them. So here I'm going to get an a minus b over top of a c. Alright, let's take a look at our first example here today. In looking at this one, I have 4x over 15 plus 8x over 15. Now, first of all, look and see. Do I have a common denominator? A 15 and a 15? Yes, we do. So we're going to add the numerators. So that's going to give me 4x plus 8x over top of 15. Or we have 4 plus 8, which gives us 12x over 15. Now, once you've added it, now let's look to see if we can simplify this in any way. And it turns out we can. I can see that 3 goes into both of these. So 3 goes into 12 4 times. 3 goes into 15 5 times. And that leaves me with a final answer of, let's see, we have 4x over a 5. Okay, now, you give this one a shot. Go ahead and pause the video for a moment, and you give this one a shot. Okay, now that you've had a chance to do this, hopefully you looked at this and you saw, common denominator, y minus 3, yep, that's a common denominator. So, you're going to add the numerators. So you will get y minus 3 over top of y minus 3. So now in looking at this, what do you see? Well, hopefully you look at this and you see y minus 3 on top, y minus 3 on the bottom, They're like binomials. Looks like those are going to divide out. So let's go ahead and divide those out. So this divides out with this. And what does it leave you with? Well, sometimes students may think, well, it doesn't leave you with anything, so the answer is 0. But that's not true. Y minus 3 goes into y minus 3 one time, leaving it 1 over 1. And 1 divided by 1 is 1. So our final answer is 1. Okay, now let's step it up a little bit. We'll see if we can get a little bit more involved here. So looking at the first one again, look at this. I have 2x squared plus a 5x minus a 12. Okay, common denominator with this over here? Yes, looks like I have a common denominator. So since I have a common denominator, I'm going to write down the 2x squared plus a 5x minus a 12 on the bottom, and I'm going to simplify what's on top. So we have a 7x minus 12, I'm going to put that in parentheses, minus, and then I have a 3x minus 6. Now, one area where students sometimes make mistakes is right here. They see a minus right there. So they tend to put the minus only with the negative, with the 3. You don't want to do that. Remember, you are subtracting this entire binomial from the first binomial. So make sure you always put the minus there and then put the parentheses there. Now I can distribute the negative inside. So let's go ahead and distribute the negative inside just like this, and we're going to rewrite this problem. So rewriting this problem, I'm going to get 7x minus 12 minus 3x plus a 6 all over top of the 2x to the second plus a 5x minus a 12. Now let's add like terms here. So first of all, let's code these a little bit. Code these like terms. So it looks like I have a 7x and a minus 3x. And now I have, let's see, a minus 12 and a 6. So we can add those like terms together. So in adding those like terms together, it looks like we're going to end up with 4x minus 6 all over top of the 2x to the second plus a 5x minus a 12. All right, now let's see if we can factor this a little bit and see if we can simplify. Now I want you to see something. This problem now turns into a problem like we did in section 8.2, where you have a rational expression and you need to factor the numerator and denominator and simplify. So first of all, let's ask ourselves, what will factor out of the 2x minus 6? Is there a common denominator? And yes, it is. So you can factor out a 2, and you're left with a 2x minus a 3 on top. Now, on the bottom, you're going to factor it as a trinomial. So look at it here, and first of all, what do you see? Look here, and here. Do you see a common factor there? And nope, I don't see a common factor. So our task is to see what we can do. So let me scoot this over a little bit, and let's just see if I can write this out and see if we can come up with the different factor choices that we are looking for. So let's see. So if I write a say 2x to the second plus a 5x minus a 12, let's see, here's going to be 1 times 2, 2 times 1, and over here it's going to be, say, negative 3 times 4, negative 4 times 3, negative 2 times 6, negative 6 times 2, negative 1 times 12, negative 12 times 1. And let's see which one of these is going to work. Looks like this choice right there is going to work.
Can we get a custodian to the comments area? Custodian to the...
Okay, so let's go ahead and let's write these factors here. And let's see, it's going to be 2x and 1x and a minus 3 and a plus 4. Now let's look to see if anything will factor out or will divide out. And yes, the 2x minus 3, 2x minus 3 divide out, and that leaves me for a final answer of, I have a 2 on top, and I have an x plus a 4 on the bottom. And there's my final answer. For the next part of the lesson, I'm going to teach you how to find the least common multiple between two binomials. Okay, so start with here, step number 1, factor each of the polynomials. So if I take the polynomials, and in the first one you can see that I can factor out a 4. So let's go ahead and we're going to factor out a 4 here. So I have 4 times the quantity, w minus a 3. And the second one I can factor out a 2, and I'm going to get w minus 3. Okay, now here I'm going to go one step further, and I'm going to put 2 squared times w minus 3, and I have 2 to the first times w minus 3. Alright, now let's list all the different types of factors that we have. Well, the first type of factor I have here is I have a 2. And I also have a w minus 3. So let's make a list of those. So I have a 2. Let me put a semicolon there. My second factor is a w minus 3. Now, next, let's find that least common multiple. And in order to find that least common multiple, we're going to write down the most of each factor. So for the first one, I'm going to write down a 2. Now let's compare a little bit here. If I take a look at this 2, I have 1 2 here, and over here I have 2 2's. Now which is the most? 2 2's or 1 2? Well, of course, 2 2's are. So we're going to put a little 2 right there. Next, what about the other factor? W minus 3. And if I look at those, I have 1 here, there's no power, so that means there's just 1. And over here there's no power, so there's just 1. So they both have 1, so I'm just going to take one of them. Now, let's identify that least common multiple. So my least common multiple is going to be 4 times the quantity w minus 3. And that is the least common multiple of these two binomials up here. Let's look at another example of finding the least common multiple. This time I'm going to give you 2 polynomials. The first one is 2w to the second power minus 12w plus 18. And the second one is going to be 4w to the second minus 36. I want you to pause the video for a moment, and I want you to see if you, using the first example, find the least common multiple of these 2 polynomials. Now that you've had a minute to play with these, let's go ahead and work it together. And looking at the first one here, I need to factor both of them first. So I'm going to factor a 2 out of here, giving me w squared minus 6w plus 9. Now from here, this is a trinomial, so we're going to tree it out, and I see it's going to be negative 3 times negative 3. So it's going to give me 2 times the quantity, and I'm going to get a w minus 3 and w minus 3. Alright, so now let's look at the second one here. Let me draw a little separator here. For the second one here, I can factor out a 4, and I'm going to get a w squared minus 9. So let's see, that 4, I'm going to write it as 2 to the second power, and the w squared minus 9 is going to be w minus 3, and then w plus 3. Alright, now let's make a list of all the different factors that we have here. So looking here, I can see I have a 2, I can see I have a w minus 3, and I can see that I have a w plus 4. So let's write those factors down here. So let's see here. I'm going to put the 2, put a semicolon there to separate it. Then I have a w minus 3. Okay, and then I have a w plus 3. Okay, so those are my 3 factors. So let's take a look at each one of these. And okay, so who has the most 2? So let's put a 2 there. And let's see, this one I have 1, 2, and this one I have 2 2's. So which is the most, 1, 2 or 2 2's? Well, 2 of course, so I'm going to take a w to the second power. Next, let's take a look at the w minus 3. And if I go over here, I have a w minus 3, I have one there, I have another one there, so that's the same as w minus 3 squared. And over here I have 1w minus 3, so I'm going to take the most, so I'm going to take w minus 3 to the second power. And now let's put the w plus 3 there, and with the w plus 3, let's see, let's compare. I have 1w plus 3 here, and I'm looking over here, I don't see any w plus 3's over there, so I'm going to just take the 1w plus 3. So my final answer here in this problem is my LCM is going to be equal to 4, then I'm going to have a w minus 3, the quantity squared, and then a w plus 3. And that is my LCM. That about wraps it up for today. Tonight I'd like you to work through section 8.3, 2 through 6, 17 through 21, 58, and then 62 to 64. Now we are going to spend 3 days on this section 8.3. Now I want to let you know on something coming up here pretty soon. We have a quiz that we're going to review for here next class period. Now the quiz is going to be over both sections, both section 8.2 day 1, 8.2 day 2, and 8.3 day 1. So it's going to be over those 3 days material. Alright, well that wraps it up for today. Have a good day and enjoy life, love, and math.